Good morning, students and parents. Welcome back to Mathematics 9 discussion via Facebook Live. Before we start our lesson, make sure that your learning packet is open on mathematics page. You must also have your pen and your notebook with you so that you can take down some important notes during discussion. If you are ready, then let us begin. Our today's lesson is about graph of quadratic function. At the end of the discussion, you must be able to determine the axis of symmetry, vertex, and direction of the opening of the parabola. Second, identify the maximum and minimum value of the quadratic function. Lastly, analyze the effect of changing the values of a, h, and k in a vertex form of quadratic function. Since we are talking about the graph of quadratic function, let us have a short activity as a recap of the said topic. In this activity, you are going to answer the questions using like or care button which corresponds to your answer. Are you ready? Let's begin. Number 1. Which of the two is the vertex form of quadratic function? 5 seconds. Is it a like or care? Timer starts now. Time is up. The correct answer is like. F of x is equal to a multiplied by the square of x minus h plus k. Number 2. Which of the two is the vertex of f of x is equal to 2 multiplied by the square of x minus 3 minus 7? 5 seconds. Is it a like or care? Timer starts now. Time is up. The answer is care. 3, -7. Since the given is a quadratic function in vertex form, it is easy to identify the vertex. But you may be wondering why the first coordinate of the vertex is +3 and not -3. The binomial in the quadratic term of the vertex form is expressed as a difference, which is x minus h. H is positive in this form as given in this illustration, while k follows the sign next to it. Hence, the vertex is h, k. On the other hand, if the binomial in quadratic term is expressed as a sum, like in this illustration, x plus h, which is the binomial term, it can be re-expressed as x minus -h. Hence, h here is negative. We have here negative h, k for the vertex. Number 3. The domain of f of x is equal to 2 multiplied by the square of x minus 3 minus 7 is set of rational numbers. Is it true or false? 5 seconds. Like or care? Timer starts now. Time is up. If you answered care, you are correct. False. The domain of quadratic function is the set of real numbers, or in symbol, r, or the notation negative infinity to positive infinity. Next, number 4. The range of f of x is equal to 2 times the square of x minus 3 minus 7 is y, the set y, such that y is greater than or equal to -7. Is it true or false? 5 seconds. Like or care? Timer starts now. Time is up. So the answer is like. It is true. The range of the quadratic function depends on the value of k and opening of the graph. If it opens upward, then the range is the set y such that y is greater than equal to k. But if it opens downward, then the range is the set of y such that y is less than or equal to k. And for the last question, number 5. What is the y-intercept of the quadratic function f of x is equal to 2x squared minus 12x plus 11? 5 seconds. Is it like or care? Timer starts now. Time is up. The answer is yes, this is like 11, 0. To get y-intercept, we have to let x is equal to 0. I'm sorry, it's 0, 11. We have to let x is equal to 0. Find the value of the given function where x is equal to 0. And that is 11. Since y-intercept is a point where the parabola crosses the y-axis, it is given by 0, 11. You can also determine y-intercept easily when it is in standard form. That is given by the constant c. Take note that x-intercept is a point where y is equal to 0 given by the ordered pair x, 0. And it is where the parabola crosses the x-axis. The x-intercept of the quadratic function is also called the zeros of the quadratic function because it is the value of x where y is equal to 0 or where the function is equal to 0. The y-intercept, on the other hand, is a point where x is equal to 0, given by 0, y. And it is where the parabola crosses the y-axis. Thank you for your very active participation in our activity. To continue our lesson, I'm going to discuss the other properties of the graph of quadratic function. The first 3 properties discussed last FB Live are domain, range, and intercepts. And for today, we will discuss the other properties of graph of quadratic function. They are vertex, line or axis of symmetry, direction or line or concavity of the graph, and lastly, maximum and minimum value of the quadratic function. Let us continue this discussion. So beginning with the vertex of parabola. In a parabola, the vertex with coordinates hk is the turning point of the graph. What is a turning point? Turning point is the point on the graph where the curve changes direction. It is the point on the graph either contains the minimum or the maximum value of the function. In a vertex form of quadratic function, the vertex can easily be determined without graphing it. The h and k will determine the vertex. That is why this form of quadratic function is called vertex form. If the quadratic function is in standard form, you can identify the coordinates of the vertex by this. H coordinate is negative b all over 2a, while k coordinate is 4ac minus b squared all over 4a. The coordinates can also be determined using this, where h is negative b over 2a also, and k is the value of the function when the value of h is substituted to the variable of the function. In the vertex form of quadratic function, f of x is equal to a times x minus h square plus k. H is positive. Here is the reason why. In the vertex form, the value of h is positive with this form if they are expressed as a difference. And in this form, if the binomial x plus h inside the parentheses, we will rewrite this as x minus negative h. That is why h is negative if the quadratic function in vertex form is f of x is equal to a multiplied by the quantity x plus h square plus k. Let us have this example. Find the vertex of f of x is equal to negative x squared plus 3x minus 2. Since the given is in standard form of quadratic function, we can use any of the two given set of coordinates with formula which I discussed a while ago. In this, we will use the 2. For the first, h and k with this corresponding formula. Since the formula requires the value of a, b, and c, determine their value from the given quadratic function. A is equal to negative 1, b is equal to 3, and c is equal to negative 2. For h, substitute the needed value in the formula. b is 3, and a is negative 1. Simplify this. 2 times negative 1 is equal to, yes, that is negative 2. Further simplifying, we get h is equal to 3 halves. On the other hand, solving for k, substitute the needed values. A is negative 1. C is negative 2. B is 3. And for the denominator, a is negative 1. Solving the numerator, 4 times negative 1 times negative 2, the product is 8. Minus, square of 3 is, yes, 9. For the denominator, 4 times negative 1 is negative 4. Further simplifying, 8 minus 9 is equal to negative 1. Then copy negative 4. And negative 1 divided by negative 4 is 1/4. Now that h and k were solved, we can write the vertex with coordinates 3 halves and 1/4. Next is same example, but we will try the another set of coordinates. This time, I will show you using the formula for solving k while the formula for h will remain the same. We were able to solve for h a while ago, and that is 3 halves. Let us solve for k using this formula. F of negative of b over 2a. In here, evaluate the given function using the value of negative b over 2a. Or in short, substitute the value of h, which is 3 halves. Thus, we have f of 3 halves is equal to the negative of square of 3 halves plus 3 times 3 halves minus 2. Simplify it. The square of 3 halves is 9 over 4 times the negative, we have negative 9 over 4. 3 times 3 halves is 9 halves and copy negative 2. Further simplifying, we have f of 3 halves is equal to 1/4. Since k is equal to f of 3 halves, therefore k is equal to 1/4. Therefore, the vertex has the coordinates 3 halves and 1/4. And this is also the coordinates we got using the other formula for k in the first solution. Another example. Find the vertex of g of x is equal to 2 multiplied by the square of x plus 3 plus 1. The given quadratic function is in vertex form, so it is easy to find the vertex. The quadratic term is in the form a and multiplied by the square of x plus h. So the value of h is -3. And the value of k is 1. Thus, the vertex is given by the ordered pair -3 and 1. Wow, that is very easy, isn't it? Just remember that if the quadratic term is a multiplied by the square of x minus h, then the value of h is positive. And if the quadratic term is a multiplied by the square of x plus h, then the value of h is negative. Next property after the vertex, we have the direction of the opening. The direction of the opening of the parabola is also named as concavity of the parabola. If a is greater than 0, then the parabola opens upward, as you can see in the illustration. While if a is less than 0, then the parabola opens downward, as illustrated here. Try these examples. What is the direction of the opening of the parabola of the quadratic function f of x is equal to x squared plus 4x plus 9? Pardon me for not writing the question mark. What do you think? If you are thinking of upward, then you are correct. The value of a is positive 1, and 1 is greater than 0. Therefore, the opening of the parabola is upward. Number 2. What is the direction of the opening of the parabola of the quadratic function g of x is equal to 15 minus 8x minus x squared? Again, pardon me for not writing the question mark. What do you think? If you answer downward, then you are correct. The value of a is -1. And -1 is less than 0. Therefore, the opening of the parabola is downward. Let us proceed to the next property of the parabola, the line or axis of symmetry. In a parabola, it is the line that divides the parabola into two equal regions. It passes through the axis of, or the x-axis at the value of h in the vertex hk. And its equation is given by x is equal to h. Let us find the equation of axis of symmetry in this example. What is the equation of the axis of symmetry of f of x is equal to x squared minus 4x plus 1. Since the equation of axis of symmetry is x is equal to h, determine the value of h using negative of b over 2a. In the given quadratic function, b is -4 and a is 1. Substitute these values in the formula. B is -4 and a is 1. Simplifying the denominator, 2 times 1 is 2. Further simplifying, -4 divided by 2 is -2. Multiply -2 by the negative, the product is +2. Since the equation of the axis of symmetry is x is equal to h, then its equation is x is equal to 2. So this is the equation of axis of symmetry. Let's continue for the next property. That is the maximum and minimum value of the quadratic function. If the opening of the parabola is upward, as you can see here, then the turning point or the vertex is the lowest or minimum point. Hence, the value of the quadratic function is minimum. And if the opening of the parabola is downward, here, the turning point or the vertex is what? The highest point. Hence, the value of the quadratic function is maximum. Take note that in a parabola, the minimum and maximum value of the quadratic function is determined by the value of k in the vertex hk. Try these examples. Identify if the vertex is maximum or minimum and determine the maximum or minimum value of the quadratic function f of x is equal to x squared minus 4x plus 1. You can identify if the given quadratic function is maximum or minimum using the value of a. The value of a is 1. Since 1 is greater than 0, therefore, the opening is upward. And since the opening is upward, therefore, its vertex is a minimum point. For the minimum value of the given quadratic function, remember that the value of k determines the maximum or minimum value. With this, we will use this formula. K is equal to 4ac minus b squared all over 4a. Identify the values of a, b, and c. A is 1, b is negative 4, and c is 1. Substitute these values in the formula. A is 1, for C, 1, for B, negative 4. For the denominator, A is 1. Simplifying, 4 times 1 is positive 4, minus the square of negative 4 is 16. For the denominator, 4 times 1 is positive 4. Further simplifying, 4 minus 16 is negative 12. And divided by 3, or 4, that is negative 3. Thus, k is equal to negative 3. Therefore, the minimum value of the function is negative 3. Okay. Since we don't have any more example, we only have one. I'm so sorry. We only have one example. For our next discussion, graphing of quadratic function. Since you are now aware of the different properties of quadratic function, we can now proceed to graphing quadratic function. To graph a quadratic function represented by equation, determine the following. Opening of the parabola, equation of axis of symmetry, vertex, y-intercept, x-intercept, and extra points. So to do this, let me show you an example. Graph the quadratic function f of x is equal to x squared minus 2x plus 1. So we have to construct the table of values to have an organized presentation of ordered pairs. We can use at least 3 points to graph the parabola. But to get a better picture of the parabola, we will use 5 points. The coordinates of the vertex will be placed in the middle column of the table of values. Let us begin now. So starting with identifying the opening of the parabola. Since A is equal to 1, the parabola opens upward. Second step, determine the axis of symmetry using H is equal to negative of B over 2A. Then substitute the needed values. In the given quadratic function, the value of B is negative 2 and the value of A is 1. Simplify this, we get H is equal to 1. Therefore, the equation of the axis of symmetry is x is equal to 1. Third, determine the vertex of the parabola. From the equation of axis of symmetry, the value of H is 1. And using this value, we will find the value of K by substituting 1 in the given quadratic function. Thus, f of 1 is equal to square of 1 minus 2 times 1 plus 1. Hence, f of 1 is equal to 0. Therefore, the vertex is 1 and 0. 1, 0 is the vertex of the parabola and is one of the points that lies in the parabola. Now, we can replace the h and k with its corresponding value. H is 1 and k is 0. Complete the possible values of x on the left, 0 and negative 1. And on the right side of h, 2 and 3. Next, determine the y-intercept. To do this, solve for the function where x is equal to 0. Thus, f of 0 is equal to 0 squared minus 2 times 0 plus 1. Simplifying this, f of 0 is equal to 1. Therefore, y-intercept is 0, 1. 0, 1 is also a point that lies on the parabola. From the table, find the column where x is 0 and put 1 as the value of f of x. Next, determine the x-intercept by setting the value of the function to 0. Thus, 0 is equal to x squared minus 2x plus 1. Using factoring method, 0 is equal to quantity x minus 1 times the quantity x minus 1, or we can simply express this as 0 is equal to the square of x minus 1. With this, we have one rational root, and that is x is equal to 1 by applying the zero product property and symmetric property. Therefore, the x-intercept is 1, 0. 1, 0 is another point that lies on the parabola. Notice that the coordinates of the x-intercept and the vertex is the same. This means that the vertex of the parabola intersects the x-axis or is lying on the x-axis. To complete the table of values, we have to find extra points by substituting negative 1, positive 2, and positive 3 as the value of x in the function. For x is equal to negative 1, f of negative 1 is equal to the square of negative 1 minus 2 times negative 1 plus 1. The value of the function is 4. For x is equal to 2, f of 2 is equal to the square of 2 minus 2 times 2 plus 1. Thus, the value of the function where x is 2 is equal to 1. For x is equal to 3, f of 3 is equal to the square of 3 minus 2 times 3 plus 1. The value of the function where x is equal to 3 is 4. Since 5 points were determined, plot these points on the Cartesian plane. For negative 1, 4, 0, 1, 1, 0, 2, 1, 3, 4. After plotting these points, trace the graph. And this is the graph of f of x is equal to x squared minus 2x plus 1. We can now identify its properties. The graph opens upward. The vertex is 1, 0. The vertex is a minimum point with a minimum value of, yes, this is 0. The equation of axis of symmetry is x is equal to 1. The x-intercept is the same as the coordinates of the vertex since the vertex lies on the x-axis. The y-intercept is 0, 1 because it is the point on the parabola that crosses the y-axis. The domain is the set of real numbers and the range is the set of y such that y is greater than or equal to 0. Did you follow? I hope you're not missing move for hiding during the solution. Let us now proceed to the last part of our lesson, which is the effect of changing the values of a, h, and k in f of x is equal to a multiplied by the square of x minus h plus k, or in vertex form. What do you think is the effect of changing their values? Let us begin with a. The change in the value of a is the change in the width of the opening of the parabola. Let me show you the illustration. First graph. So this is the graph of y is equal to x squared. For the second graph, this is the graph, the color blue, the graph of y is equal to 2x squared. For the third graph, this is the graph of y is equal to 1/2 square, x squared. What do you notice on each graph? The value of a for y is equal to x squared is 1. The value of a for y is equal to 2x squared is 2. And the value of a for y is equal to 1/2 is, 1/2 x squared is 1/2. Y is equal to x squared is called the parent function or simplest function of quadratic function. And using this function, it gives the simplest parabola of quadratic function. In this function and graph, a is equal to 1. The graph narrows as a increases. Do you see the changes in the width? While when a is less than 1, the graph what? It widened, as you can see in the graph. So, it can be summarized to, if the absolute value of a is greater than 1, then its graph is narrower than y is equal to ax squared. If the absolute value of a is greater than 0, but less than 1, meaning to say, the absolute value of a is between 0 and 1, then its graph is wider than y is equal to ax squared. Which means As a approaches 0, but will never be equal to 0, the graph widened. In our previous illustration, it showed that the graph of y is equal to 2x squared is narrower than the graph of x squared. The graph of y is equal to 1/2 x squared is wider than the graph of y is equal to x squared. I hope you get that. Let us proceed to change in h. The change in the value of h translates the parabola horizontally. If h is greater than 0, then the graph translates h units to the right. And if h is less than 0, then the graph translates h units to the left. Let me show you some examples. Describe the translation of the graph of y is equal to the square of x minus 2 from the graph of y is equal to x squared. Showing the graph of y is equal to x squared and y is equal to the square of x minus 2. In the quadratic function y is equal to x squared, the value of h is 0, while h is 2 in this function. When the value of h increases by 2, the graph moves horizontally 2 units to the right of y is equal to x squared. Next illustration, number 2 example. Describe the translation of the graph of y is equal to the square of x plus 2 from the graph of y is equal to x squared. The graph of y is equal to x squared is this, with h is equal to 0. The graph of y is equal to a times the square of x plus 2 is given by the blue parabola, with h is equal to negative 2. The graph translates 2 units to the left of y is equal to x squared. The value of h in the blue parabola is negative 2. So, the graph moved horizontally 2 units to the left of y is equal to x squared. And for the change in the value of k, it translates the parabola vertically. If k is greater than 0, then the parabola is translated k units upward. But if k is less than 0, then the parabola is translated k units downward. Look at these examples. Describe the translation of the graph of y is equal to x squared plus 2 from the graph of y is equal to x squared. Showing the graph of y is equal to x squared and the graph of y is equal to x squared plus 2. The graph translates 2 units upward. There. The graph of y is equal to x squared plus 2 translates vertically upward by 2 units from the graph of y is equal to x squared. Number 2. Describe the translation of the graph of y is equal to x squared minus 2 from the graph of y is equal to x squared. Showing the graph of y is equal to x squared and the graph of y is equal to x squared minus 2. In the quadratic function y is equal to x squared, the value of k is 0, and in y is equal to x squared minus 2, the value of k is negative 2. Thus, we can say that the graph of y is equal to x squared minus 2 was formed by translating vertically downward 2 units the graph of y is equal to x squared. There. Let us now see the translation of the graph of y is equal to a times x, the square of x minus h plus k when both values of h and k change. Given the graph of f of x is equal to ax squared, to graph the function f of x is equal to a times the square of x minus h plus k, slide the graph of f of x is equal to ax squared, h units horizontally, whether right or left, and k units vertically, whether upward or downward. To illustrate this, let us have this example. Draw the graph of the following quadratic functions on the same coordinate plane. I will be out again. So using this parabola, for f of x is equal to x squared, since h is equal to 0 and k is equal to 0, the vertex is the point of origin. The graph is this. For f of x is equal to the square of x minus 1 plus 1, h is equal to 1, and k is equal to 1. From the graph of f of x is equal to x squared, the color red, parabola, move 1 unit horizontally to the right and 1 unit vertically upward. Why to the right? Because h is positive 1 and k is positive 1. For f of x is equal to the square of x minus 2 minus 2. H is equal to positive 2 and k is equal to negative 2. From the graph of f of x is equal to x squared, the color red, move 2 units horizontally to the right because h is positive. And 2 units vertically downward because k is negative. And that is the graph of f of x is equal to the square of x minus 2 minus 2. For f of x is equal to the square of x plus 1 plus 1. H is equal to negative 1 and k is equal to 1. From the graph of f of x is equal to x squared, move 1 unit horizontally to the left and 1 unit vertically upward. And that is the graph of f of x is equal to the square of x plus 1 plus 1. For f of x is equal to the square of x plus 2 minus 2, h is equal to negative 2, k is equal to negative 2. From the graph of f of x is equal to x squared, move 2 units horizontally to the left. 1, 2. And 2 units vertically downward. 1, 2. And that is the graph. Wow! Mathematics is so amazing. I hope you learned a lot from our today's discussion. For our generalization, let us sum up everything we discussed today. The properties of the graph of quadratic function are domain, range, intercepts, the x and y intercept, vertex, line or axis of symmetry, direction of the opening, and maximum and minimum value of quadratic function. To graph a quadratic function, follow these steps. Determine the opening of the parabola. Second, determine the axis of symmetry, followed by determine the vertex. Next, determine the y-intercept. Next, the x-intercept. And then determine extra points. When it is completed, plot these points and trace the graph. The effect of change in the value of a, h, and k. The change in the value of a is the change in the width of the opening of the parabola, while the change in the value of h is the movement of the parabola horizontally. And the change in the value of k is the movement or translation of the parabola vertically. Let us now proceed to our question and answer. Our teacher moderator will randomly select questions coming from the comment section and private messages. Okay, so we are still waiting for the question to be given by the moderator. Okay, we got a question here. Okay, is it possible that the parabola opens to the left and to the right for quadratic function? A parabola can be opens to the left or to the right. But when it comes to being a function, a parabola that opens to the left and to the right does not define a function. Therefore, a parabola that opens to the left and to the right does not define a quadratic function. Because if you will try to pass through a vertical line, applying the vertical line test, you will see that there will be 2 points in the parabola that will be intersected by the vertical line. Okay, so there's another question. Okay, so the question is, will it be possible to graph a quadratic function if the given is vertex form? Okay, so yes, it is possible. I think for me, it is easier to graph a quadratic function if it is in vertex form because the vertex is already given. And when the vertex is given, you can see now the midpoint of the table. So you can simply apply the evaluation of function by substituting 2 values to the left of h and 2 values to the right of h in the given quadratic function formed in vertex form. Okay, so there's a lot of questions still coming. Okay, so I'm afraid that the time allotted for this session is coming up to its end. I'm sorry for that. So maybe your discussion teacher will entertain your questions during your follow-up discussion tomorrow. And for your assignment, answer try this of pages 33 and 35 of your learning packets. With this, I'm glad to be your live streaming teacher for today. Have fun learning, everyone. God bless you all.